So hi, I'm Harshit and today I'm gonna try solving a problem which Google can't fix. And it's not because of the fact that Google doesn't know the problem existed, but solving this problem creates an even bigger problem. And after digging into how search engines actually work, I understood this must be one of the most interesting problems on the internet. So yes, let's try to solve it. So let's start with a simple search. Let me search something like latest AI model say released. So this might sound like a normal search, but Google immediately has a difficult decision to make. Should it show the newest information or the most trustworthy information? Because the newest information is usually the least verified, and the most trustworthy information is usually the least recent. If Google prioritizes freshness, spam and misinformation can rise to the top. Discoveries, but if Google prioritizes trust, new discoveries can get buried. And that's the problem. To understand why this happens, we need to understand how Google search actually works. And now let's understand how Google search actually works. And everything starts with the internet. So there are billions of web pages being created, updated, and edited every day. Obviously, Google can't search the entire internet every time someone types a query. And that would be way too slow. So instead, Google continuously scans the internet before anyone even performs the search. And the next comes web crawlers. Think of them as tiny robots constantly exploring the web. They visit websites, read pages, discover the links, and follow those links to new pages. If a website publishes a new article, there is a good chance a crawler will eventually find it. The crawler's job is simple: find an information and bring it back to Google. And the next comes indexing system. Once Google finds a page, it doesn't immediately show it on the search result. First, it has to understand what the page is about. This process is called indexing. Google analyzes the content, extracts the important information, analyzes the keywords and topics, language, and relationship between the pages. You can think of this like organizing the books inside a giant library. Before people can find a book, someone has to place it in the correct section. And next we go to search index. After indexing, the page is stored in Google's search index. This is basically a massive data set of information collected from the web. And this is one of the most important part of the system. When you search something, Google is not searching the entire internet. It's searching this index. That's what makes search so fast. So instead of scanning billions of pages in real time, Google searches its pre-built database. So far, everything is relatively straightforward. But the next step is where things get interesting. And next comes the ranking engine. Imagine I search for like latest AI models released. Google's index might contain millions of pages related to the topic, but I only need to see like 10 results on the first page. So how does Google decide which 10 deserve to be there? That's the job of the ranking engine. So let's start with the first one, the relevance. Does this page actually answer my question? Is what this is for. A page talking about football is probably not relevant to an AI search query. And the next one is authority. So, can this source be trusted? A research paper or official documentation may be considered more authoritative than a random blog. And the next comes freshness. So, was this information published recently? This becomes extremely important for news, technology, and rapid changing topics. And the next comes popularity. So, popularity helps Google understand whether people actually find this content useful. Are people clicking it? Are other websites liking to it? Is it being referenced across the web? So, all such things. And the next comes user signals. If people click a result and immediately leave, that's probably not a great sign. If users consistently find value in a page, that's a stronger signal that the result deserves a higher position. So that is what user signal is meant for. And the last is search results. After evaluating all the signals, Google generates the final ranking and shows the results to the user. And this is where I found something interesting. Because some of these signals work together, but some of them directly fight each other. Specifically, these two, authority and freshness. Because the most trustworthy information is often older, and the newest information is often the least trustworthy. And that's where the problem begins. And yeah, the problem is not with the crawlers or the indexing system, rather, it is in the ranking engine. And to understand it clearly, let's understand the trade off. Let's imagine a new AI model launches today. Let's imagine a new AI model launches today. A Reddit thread discussing it appears immediately, and a blog article appears a few hours later, and its official documentation arrives the next day, and all the academic analysis arrives a week later. Which result should be ranked first? The Reddit post is fresh, but maybe inaccurate. The official documentation is trustworthy, but it is slower. And the academic analysis is even more trustworthy, but much later. There is no perfect answer to this. And this is where Google's ranking problem begins. Every search query requires a different balance between trust and freshness. So, searching latest AI model requires freshness, and searching something like heart attack symptoms or something like that requires trust. While searching something more like election results or campaign results, they require both. And a single ranking system has to somehow handle all of them. At this point, I started wondering if researchers had already looked at this problem. So when I went digging, I ended up reading Google's original research paper by Larry Page and Sergey Brin, along with Google's own documentation on ranking systems. And what I found was quite interesting because Google's original ranking system was heavily based on authority. Page becomes trustworthy over time through links, reference, and reputation. But freshness doesn't have time to build authority. A brand new piece of information starts with almost no trust signals. Then I looked at Google's modern ranking systems. One thing anymore. And Google isn't optimizing for one thing anymore. It's balancing freshness, quality, authority, relevance, user satisfaction, and many other signals simultaneously. And that's when I realized something. Maybe the problem isn't that Google lacks enough ranking signals. Maybe the problem is that freshness and trust are being forced to compete inside the same ranking process. So earlier we saw how Google combines many ranking signals into a single ranking process. But after reading the Google's paper and documentation, I started wondering, what if freshness and trust shouldn't compete inside the same ranking system? What if they should be evaluated independently? That's the architecture I came up with. So the user query. Everything starts with a user search query. Let's use like the latest AI model as an example. The goal isn't just to find the matching pages anymore. The goal is to understand what kind of search this actually is. So that is done by the intent analyzer. The first component here is the intent analyzer. This module tries to understand what the user is actually looking for. Is the user searching for a breaking news or a medical advice, a historical information, or anything else? Different queries needs different ranking strategies, and that's something traditional ranking systems often struggle with. Upon moving to context classifier, once the intent is understood, the query moves here. This is probably the most important part of the architecture. So instead of immediately ranking the pages, the component decides how much importance should be given to trust and freshness. In, in other words, what balance should we use for this specific search? And if we have a closer look on the example, if someone searches latest AI model, freshness becomes extremely important. We probably care more what happened today than what happened 6 months ago. So the system might assign 80% freshness and 20% trust. And if someone searches heart attack symptoms, trust becomes more important than freshness. We don't want some random blog post written yesterday. We want reliable information. And that is why we have like 90% trust and 10% freshness. And coming back here, we have the trust path. Once those weights are determined, the query enters two completely separate ranking paths. The first is trust path. Here we have something called as a trust engine. The trust engine focuses entirely on credibility. It doesn't care how new the content is, it only asks, can this source be trusted? So here it has the authority score. The first signal here is the authority. Has this website built a reputation over the time? Is it recognized in its domain? So all such things are handled by the authority score. And the source reliability. This answers whether the source consistently provides accurate information. And then the historical credibility. Has this source been trustworthy in the past? Does it have like a history of producing high quality content? All such things. On the right side, we have the freshness path. Unlike the trust engine, this component doesn't care about long-term reputation. Its only goal is to identify the newest and most relevant information available. So first we have the recent content. The recent content checks how recently information was published. And the next one is the breaking info. The breaking information identifies emerging discussions and newly discovered information. And the last one is the latest updates. The latest updates tracks changes happening right now. This is especially important for technology, news, and rapidly changing topics. And at last, we have something called as a dynamic fusion layer. Now we reach the most important part of the system. So instead of forcing freshness and trust to fight each other from the beginning, both engines independently generate their own rankings. Only at the very end are the results combined. And the combination isn't fixed. It changes depending on the query. That's the key idea. A medical query might receive 90% trust and 10% freshness, while a breaking news query might receive 70% freshness and 30% trust. The final ranking is then generated using these adaptive weights. So instead of using one universal ranking strategy for every search on the internet, the system adapts its ranking strategy based on the user's intent. The idea here isn't Google is wrong. Google's ranking systems are incredibly sophisticated. The idea is that freshness and trust may actually be two separate optimization problems, and treating them independently might allow search engines to make better decisions for different queries. Though the architecture looked promising, but would it actually make different decisions? To find out, I created a simple simulation. Let's imagine Google found these three pages on the same topic: an official document, a Reddit discussion, and a news article. Now let's see how the ranking changes depending on the user's intent. In this search, the user wants the latest information. So the system increases the importance of freshness and reduces the importance of trust. Because a 6-month old official document isn't very useful if a new model launched yesterday. The result is that newer content rises to the top and the system prioritizes recent discoveries and breaking developments. Now let's try a completely different search: heart attack symptoms. In this case, accuracy matters far more than recency. The newest information isn't necessarily the best information. This time, the ranking changes completely. Trustworthy sources move to the top while less reliable content get pushed down. And that's when I realized something. The problem isn't finding information. The problem is deciding how information should be ranked. And different searches need different ranking strategies. So let's recap. We started by looking at how Google search works, then we found a hidden trade-off between freshness and trust. And after studying Google's architecture and ranking systems, I designed an alternative approach that evaluates those factors independently. So instead of using one ranking strategy for every search, the system adapts its behavior based on the user's intent. And on conclusion, did I solve a problem which Google can't fix? Probably not. But I think I found something interesting. Search engines aren't really trying to find information. They are trying to make decisions, and every search forces them to balance competing goals like freshness versus trust, speed versus accuracy, discovery versus reliability, and maybe there isn't a perfect solution. But exploring those trade offs is what makes building these systems so fascinating. And yes, thanks for watching.